All right, so I promised early on in this series that by the end we would be taking a random walk in 4 dimensions. Now it's hard enough to represent a random walk in 3 dimensions on a 2-dimensional screen, but I want you to think creatively for a second about what a dimension is. Remember, we had an earlier video where we took a random walk along a musical scale. So you can take a random walk in a dimension as long as that dimension has something quantifiable that you can change. And what we're going to take as our 4th dimension today is the color of the animation of our random walk. So for the first 3 dimensions, we're going to have our usual output of along the x-axis, the y-axis, or the z-axis. And for our second output, we're going to return a change in the color of the animation of the random walker. So here we have Kramer and Josh, our intrepid random walkers who have been random walking for several weeks now. And we're going to start them out with the same color. We're going to start them out with an equal amount of red and blue and no green. We're just not going to worry about green here. And so we're using here the RGB code. And so for a step in the 4th dimension, to represent that, we're going to either increase the red and decrease the blue, or decrease the red and increase the blue. The way we're going to set that up is that our new direction function is actually going to return 2 vectors. It's going to return a list of vectors. One is going to be the change in the spatial dimension, and one's going to be the change in the color dimension. So you might think of this as like representing their position in space, but also their velocity, or their speed, or their temperature, or their mass, or something like that. Some other thing that we would want to change about the object. So here we've got our step size in the spatial dimension, our step size in the color dimension, and basically what we do, after we update Kramer and Josh's position, we also update the color of the sphere representing them. Now that's also going to change the color of the trail that they make. So when you have this make trail option turned on, it leaves behind this curve of points, but when you update the color of the object, it only changes the color of the new trail that's made. It doesn't go back and retroactively change the color of the previous trail. So we're going to get these gradual changes in color over the trail to represent movement in the 4th dimension. Let me hit Control 2 and show you what I mean. So we have Josh and Kramer. They both start out kind of purple. And then one of them starts to take a step in the blue axis. One of them starts to take a step in the red axis. So they're moving away from each other along X, Y, Z, and the color axis. Well, this is moving back toward purple. It's moving closer toward blue. So you notice they take a little pause, because whenever they take a pause to move in the color dimension, they're not moving in the X, Y, or Z direction. And so this, I think, is my favorite random walk animation so far, because you get this neat little 3D maze, but you also have these changes in the color of the trail. So if you were using this to make a maze or a dungeon map or something, this could represent, you know, what kind of creatures there are in that room, or how cold or hot that room is, or something like that. Well, this one is moving way off into this direction and has then gone from blue to purple back to blue again, it looks like. Now this one's gone all the way to red. Unfortunately, there's no plaid option, so we cannot have Spaceball 1 go to plaid. And so I think this is a neat way to represent this. It kind of hopefully expands your mind a little bit to think of higher dimensions, of different ways you could represent that, but also to think of what do we mean when we say a dimension. We mean some property that has a numerical value assigned to it, and that's exactly what we've got changing here. Now, of course, the next logical question that we're going to address in the next video is a 4-dimensional random walk a transient or a recurrent random walk? Meaning, are you guaranteed to return home, or are you not guaranteed to return home in a walk in 4 dimensions? You can probably guess the answer, but I'll leave it unanswered now, and we'll take a look at it in our next video. So thank you so much for watching. I will see you next time. Bye-bye.